This conference is brought to you by CallStack, a total software engineering consultancy.
Give it up for Akshat!
Hey everyone, just a quick sound check. I'm audible? Yeah, and you can see my screen. Sorry for that. That's a normal protocol these days. Whenever you ask, am I audible, you have to say, can you see my screen? Maybe for the folks on YouTube. Cool, let's get started. So the topic for next 30 minutes is Skia meets React Native, revolutionizing mobile UI and animation, and hope I'm able to cover it in 30 minutes because we have lunch. And I don't know about you guys, but I'm excited about it because I skipped my breakfast. Cool. But before I get into the real meat, quick introduction about myself. I'm Akshat Paul, founder and CTO of Company 360. At Company 360, we are changing the way legal works in India and beyond, focusing on intellectual property instruments. Our platform empowers clients by simplifying the process of obtaining intellectual property registrations across multiple geographies. We help them do all these things, manage all their portfolio from a single platform by leveraging our proprietary databases, delivering superior advisory services. Besides that, we also have our in-house learning management system to help corporate customers deliver efficient compliance trainings. Prior to Company 360, which is my venture for the last 2 years, I've worked for a decade at McKinsey Company as a consultant, advising companies what is the latest and greatest happening in technology. I still do that to guide enterprise and companies to adopt technologies which when they are in their prime and their spring and not in their graveyard. Actually, that is where I discovered React and React Native. You can find me on Twitter or X at Paul Akshat, or just check out akshatpaul.com. My DMs are always open, so you can ping me if you have any questions related to this presentation, or if you want to discuss any problem. Not any problem, not your personal problems, only technical problems and not political at all. Beside all this, I've also authored a few books and have been a technical reviewer with Manning and A-Press in last few years on topics like React Native, Ruby development. So that's about it. Cool. Before we start the presentation, quick agenda. It's a very simple presentation, just 4 parts. Quick introduction to Skia and why exactly Skia. Then Skia, how Skia works with React Native. A few demos, because no technical presentation is complete without demos. And then future exploration, what else you can do after the end of this talk. Cool. Let's start with the introduction to Skia. So how many, just to check, how many of you have used Skia or know about Skia? All right, there are a lot of people, but I think most of you must have used some kind of 2D images, animation, graphics in your applications. And we'll see how Skia can really change the way you work in your applications going forward. So Skia is an open source 2D graphic library that provides powerful and flexible APIs for drawing shapes, text, images. It serves as a graphic engine behind many and most widely used applications and platforms these days. You might be using Skia without even knowing about it. It's everywhere. It's in mobile apps. Google Chrome is powered by it, Android, Flutter, and now even React Native. Skia is designed to be portable and efficient and work covering all form factors. Whether it's a mobile device or an iPad or a television, smart TV. So Skia is not some newbie library which has just come up and we can just try it out and forget about it. It's years and decades of work which has led to what it is today, very stable in nature. Started in 2004, Skia Inc. was founded to create high-performance, cross-platform 2D graphic library. In 2005, acquired by Google and integrated into Google ecosystem with beta projects with Google Chrome and Android. In 2008, Skia becomes open source and is officially integrated into Android. Skia is adopted as a primary graphic engine for Android operating system. Starting from its early version, it handles rendering of UI element, text, images on all your Android apps. Skia also powers Google Chrome in 2008 and becomes a core graphic engine behind Google Chrome. This integration is pivotal in building Chrome's reputation way back in 2008 as fast and reliable browser. Now we come to 2010 to 2018. There's introduction of hardware acceleration, which leverages GPU for rendering tasks. This significantly improves performance, particularly in graphic-intensive applications on mobile devices. Adoption in Flutter, officially, it's no longer a beta project. Skia is chosen as a default rendering engine for Flutter. The integration with Flutter helps deliver smooth application across platforms now. In 2018, again, Skia is introduced with Apple Metal API, enabling efficient rendering on iOS devices. And we come to 2021, when Skia is integrated with React Native, with React Native Skia, is introduced by Shopify, allowing React Native developers to leverage Skia's powerful rendering capabilities. This integration enables React Native apps to handle complex graphics, animations, and high performance with high performance and flexibility. And since then, there is no looking back. There is continuous development from contributors of Google, Shopify, and the open source community. So, but since so animation is not that it's introduced by Skia, there are options even before that. And why should we jump into it? Of course, there's a long history to it, and it's a pretty stable library now. But there are some other options. The most common ones you would be questioning is that why can't I just use images? They work cross-platform. If I use SVG, it's resolution independent and can scale infinitely. But there are inherent issues if you use images. A lot of apps use it and still use it, but there are inherent issues. PNGs are static images, and they cannot adapt on user interaction. SVGs, though scalable, they aren't inherently dynamic and requires a lot of additional code and libraries in order to make them animate and make them more interactive. There are, of course, performance issues, as I mentioned, scalability and interactions. So while PNG and SVG have their place, there are a lot of trade-offs which comes with them. They can be used in part of the applications, but if you look at all modern applications, it's not something very user-friendly for them. Then there are libraries like Lottie, which works best for animations, but for that you have to use third-party tools like After Effects and then import it. It's very easy to use it through JSON, but the real problem is that the real-time manipulation of animation is not possible once it is embedded into the application. Then we have reanimated and gesture handler for basic animation, but the more advanced, complex shapes, paths, effects, it's not very successful in that. Then, of course, we can use libraries like 3JS, which excel in 3D rendering, but isn't optimized for mobile 2D graphics. And in most of the mobile apps, especially if you see, they are all flat designed, and they need 2D graphics for all the interactions. So, but do we actually need so much of interaction and interactive content for our applications? Of course, we do not. We never needed them. If we go back 10 years, simple click and images here and there would work. But in modern days, even simple banking applications, as you can see, one of the sanitized example here, even they require interactions and animations in order to make user activity better. These visual cues and micro interactions really help user to stay connected with your application. It also gives a notion, it also gives an idea to customer or user that, that the loading, that we can hide the load time behind these animation, and customer continues to use the application and feel that the application is faster and slightly sophisticated. It is a sleight of a hand, but very commonly used. We no longer can use a loading GIF in modern applications. Then, of course, there is brand identity and aesthetics. Animation plays a critical role in reinforcing brand identity and aesthetics, and also creating memorable brand experiences for any application. There's also enhanced user experience, smooth transition, engagement, and retention through interactive design. And so all these factors make Skia a game changer for graphic application development. Firstly, it serves as a graphic engine for a number of significant platforms. As I mentioned, from Google Chrome to Android, Flutter, everywhere. There is portability across platforms and form factors. There is GPU acceleration, which significantly boosts performance, especially when dealing with complex graphics and animations. Moreover, Skia is open source in nature, which means that the contribution is from global community of developers and corporations. So in total, we can use different libraries and come up with the same kind of an experience. And instead, we can just use Skia and get things done at one place. And we don't have to run with various library and manage our code again and again and make our bundle really huge. Now, let's go to the next part of our presentation, which is using Skia with React Native. And it is really simple. You can simply do an npm install React Native Skia, and that's it. And you can get started. Cool. Now, the main part is our demo time. And our first demo, we will do three things. We will draw, we will add some effects, and we will animate. This is a very basic example in which I will convert a simple shape like a circle into a sphere or a ball, and then animate it, bounce it around the screen. This is like a to-do app for animation. Cool. So let me just walk you through the code, and then I'll run it on the screen. So here you can see that we start importing the necessary components which we'll use, mainly canvas, circle, and paint from React Native Skia. Canvas acts like a drawing area where we place all our graphics. It's similar to how you would use Canvas in web development for drawing 2D shapes. Next, we have our basic Skia component, which is a view container and has a standard React Native way of wrapping visual elements. Within the view, we define a canvas element so that it takes up the available space. Then we have our circle component, and it draws its coordinate. We have our x coordinate and y coordinate, and which sets up the position of the circle on the canvas with a radius. And also we have added a color, blue, here. Now let's run this code, and then we can see how it works. So let me move. Yeah. It's a little tough, when you have to handle 3 screens at a time. Okay, yeah, I'm here. Doing a demo in front of live audience is slightly nervous. You feel like you're naked on stage, and now I have made all of you uncomfortable. But we have our circle on the screen, and let me continue. If I can get my VS Code. All right, cool. So let's now convert this circle into a sphere. Yeah. Okay. Cool. So in the second part, what we are doing is it's pretty simple. That we have a component radial gradient, which uses which uses the radius. We are using two colors, and we are actually finding the center of the circle in order to create an effect. It is just an illusion. Create an effect that two colors, blue and gray, are going around and covering the entire surface, and it becomes a sphere. So that's pretty much it. And I'll just comment out. Otherwise, we'll have multiple balls on the screen. Okay. Cool. Very simple. Now we have converted a sphere into a circle into a sphere. Sorry. Now let me take you to the next part, which is how we can animate this sphere. Yeah. So in the first part of the code, we have set up the foundation, and now what we'll do is that we'll use state to manage two key properties, which is vertical position of the wall and the vertical scaling, both on y-axis. We have set it to 150 so that the sphere is near to the top of the screen, and then we'll move it around the screen with the use effect hook. We have a bounce animation setup where we change the position of the y-axis to 400 and then return it back to 150 in 1 second. This creates an upward bounce. The scale animation gives a bounce realistic effect by shrinking the height to 0.8, and then which gives an illusion of a squash, and then restore it to 1 after 500 milliseconds. We use set interval to repeat both the bouncing and scaling animations together in 2 seconds, and this gives us a continuous rhythmic bounce effect, which eventually gives us a feel that there is an animation happening. Yeah, sure. Too big. Yeah. Yes. I have the code in my slides too, so I'll share it, and also this GitHub repo, and you can have a look at it. So let me just run it. Cool. Now, this is a very, very rudimentary example, and now we can go back to our slides to understand how animation works. And we are not using any additional library here, if you see. We can then scale it up to a more refined animations, and which we will do in the second example. Let me go back to my presentation. So this was just a backup in case my demo fails, and as you saw, there's a very high chance of it that it fails. So I'll stick to my slides now. Cool. Now let's move to a more advanced React animation. So now we'll build this application. Of course, I'll explain it through my slides, because back and forth is taking more time. And here we are going to build some sprinkle effect, and let's see how we can do that. Before we dive into creating the sprinkle animation, let's talk about the tools we are going to build. These are essential ingredients to bring animation to life in this specific demo. We have few Skia imports here, canvas, as I had mentioned earlier. Then we have group, which imagine group as a container that let you apply transformation to multiple elements at once. We have rounded rect, that is that's to create a rectangle with rounded corners. We'll be using them to create individual sprinkle pieces. Then we have run timing. Then we have Skia, of course, from React Native Skia. We'll use computed value and use value. We have few redash imports, specifically process transform 3D, which gets, this function is responsible for transformations like rotations and 3D effects. When we apply it on individual sprinkles, that is how it gives those just tiny lines, they get those 3D effects and of falling. So these are the basic stuff we are importing. Next, we have set up few constants to control our sprinkle animation. We have two colors here so that we can differentiate between two sprinkles. We have count. We have added a count so that we can add up more or less. Then we have screen height and screen width. We are picking up the device screen so that our app works across various screen sizes. Then we have our calculate function, which is some mathematics you can see here. We calculate values based on the vertical position. And then we have some sine and cos functions that create wave-like motion for our animation. Next part is we now get into our sprinkle element component. There we have properties of initial X, Y, ID, color index, which helps us understand the initial position of our sprinkle lines. Then we have element width and height, which helps us define size of each sprinkle. Then we have added a random factor in order to bring some randomness in this animation. And this is the reason why each and every sprinkle will, if you look at it closely, it will look unique in itself. Next, we are using animation timing here. The run timing, this function animates the vertical position, Y position of the sprinkle from its initial position down to the bottom of the screen in 3.5 seconds. This creates an illusion of falling in a wave down at the screen. Now let's look how we have applied these transformations to each sprinkle and how it is rendered on screen. We have transformation metrics, which is using use computed value. We calculate the transformation that will be applied to each sprinkle, rotating them around X, Y, and Z axis. This gives our sprinkles a dynamic 3D light effect when they fall. We also have rotation along X, Y, and Z. These values are calculated using calculate function combined with the random factor, as I had discussed earlier. Then we have group component that applies transformation metrics and sets the origin of these transformations. Inside group, we have rounded rect, which gives the rounded effect to these individual sprinkles. This part of the code is what makes those lines into a sprinkle and rotating and moving them and makes the animation feel rich and dynamic in nature. Now let's look at our sprinkle component and bring everything together. The sprinkle element and set sprinkle element state holds the array of all sprinkle elements that will be animated. It's initialized as an empty array initially. Then we have just put a title and set title just to add some interaction in the application. And then we have our start animation function and color assignment. Color assignment is based on the ID. As the ID changes, whether it is odd or even, the color assignment will change. Finally, we have an interaction title to be changed, just to add a bit of interaction in this, not just a random animation. Finally, we have this render function where everything comes together. The view is the main container. The canvas is where all the sprinkles will be drawn. Then we have a pressable title, and we have a pressable start button. And that's all. That's about the whole structure of this short component. Finally, some styling, some colors, which are quite self-explanatory. Now let's get back into the demo. Cool. And that's. Sorry for the speedy explanation, but that's the best I could do in order to put it all in 30 minutes. And that's a wrap for the demo part. I still have a few more slides. All right, let's go back. OK, I had a lot of backups. You can find this code on my GitHub, both the demos. You can download them, play around, maybe walk around with this talk once it's on YouTube, and you can try it out. So now what's next? There are a lot more things which you can do with Skia. It's not just about the basic animations. You can try a few other libraries and other things like shaders in Skia. Shaders are very powerful tool that allow developers to create complex visual effects by manipulating pixels on the screen. They operate at a very low level and giving you fine-grained control over how your graphics are rendered. You can try shaders.skia.org as a playground, and you can try it out and then maybe import it in your applications. Then, of course, Skia works very well with other libraries, further improving the experience and enhancing your capability of your application. You can use React Native gesture. You can use React Native Animated, which works well with Skia to create dynamic, interactive animation, which are crucial for high-performance application. There is also React Native Gesture Handler. By combining Gesture Handler with Skia, you can create highly responsive, touch-based interactions, such as drawing, and ensure that touch interactions are smooth in your application. They work really well. And a few references you can refer if you want to start up with Skia in your application. There is getting started documentation from Shopify. It's a really good source. You can get access, see all the methods and functions you can use with React Native Skia. Of course, shaders. Playground is a good place to try shaders. Then, of course, Shopify blog is a great place to stay updated with Skia, even if you're not using all its features. But it's my go-to place to stay updated. Then, of course, Dan from Shopify, his GitHub repo is really cool. It has a lot of great examples in order to understand the fundamentals, how animation works. And of course, if you have seen William's YouTube channel, he's now moving a lot into React Native Skia demos. And if you followed this series of can this be done with React Native, all those fancy UI can now easily be done, which was very complicated earlier with Skia. So now that's a wrap. And thank you all for joining. I think I'm right in time. And you can definitely connect with me on my Twitter. And if you have any questions, I'm available throughout the day and, of course, even after the conference. Thank you, everyone.